Okay, so in this video, I'm going to take you through the 2020 exams. This is the A-Level Maths Paper 1, Pure Mathematics. And obviously they weren't sat in the summer, but they were sat later on that year for private candidates. So let's begin right away. It says, find the first four terms in ascending powers of x of the binomial expansion of 1 plus 8x to the power of a half, giving each term in its simplest form. So we know for this that there's a particular formula when you do it. You have 1 plus x to the power of n. You just get 1 plus nx plus n minus 1 over 2 factorial, which is just 2, x squared. And you can see the pattern. It goes n minus 1, n minus 2. This would be over 3 factorial, and that would be with x cubed. So we're just going to do exactly the same thing as that formula, but it's going to be with 1 plus 8x to the power of a half. So in this case, n is equal to a half, and our x term that we've got is actually 8x. So we're going to be very careful with our substitution. We'll get 1 plus a half multiplied by our x term, which is 8x. Then we're going to get a half for n. We'll do a half take away 1, which is minus a half, and you'll divide that by 2, and that's multiplied by our x term squared. And then for our fourth one, we're going to have a half multiplied by a half minus 1, and a half minus 2, make it decrease by 1 again, and 3 factorial is 3 times 2 times 1, which is 6, and then we have 8x cubed for this bit. So the first term is just a 1. A half of 8x is just going to be 4x. Now this next one, we can tell it's going to be a negative, so I'm going to start with the negative, and then I'm going to just quickly do the calculation that goes with this one. So I'm going to be doing a half multiplied by a half. I'm going to divide that by 2, and then I'm going to multiply it by 8 squared, and my answer is 8, so it's minus 8x squared. Now for the other part that I'm going to do, I can tell it's going to be a plus because the two negatives are going to make a plus. This is how I would do it on my calculator. So I'm going to do a half multiplied by a half, which is the negative half, multiplied by 3 over 2, well that's 1.5. I'm going to press equals, then I'm going to divide it by 6, and then I'm going to multiply it by 8 cubed. So I get 32, so it's plus 32x cubed. And I can just put that to one side now. Okay, so now it's going to do part B of the question. Part B of the question says, explain how you could use x equals 1 over 32 in the expansion to find an approximation for root 5. There is no need to carry out the calculation. Well, if x equals 1 over 32, we would get 1 plus 8x, which is 1 plus 8 multiplied by 1 over 32 to the power of a half. So that's going to be 1 plus, well, let's just do that on the calculator. Let's just do 1 plus 8 multiplied by 1 over 32. So that is 1 plus 8 over 32. That's 5 over 4. So it's 5 over 4 to the power of a half. Now 5 over 4 to the power of a half, if I just do on my calculator, answer to the power of a half is just root 5 over 2 because it's taking the square root. So we get root 5 over 2. So this means if you substitute that x is equal to 1 over 32 in here, you'll be getting root 5 over 2. But because we want root 5, we will substitute it in here and then double our answer or multiply our answer by 2. So explain how we would use it. What we would do, I would explain by saying substitute x equals 1 over 32 into the expansion, double this answer. And that's enough to explain how we would find the square root of 5 there. Okay, let's have a look at question 2. Question 2 says, by taking logarithms of both sides, solve this equation and giving the value of p to one decimal place. So we have 4 to the power of 3p minus 1 equals 5 to the power of 210. Now you could take any logarithm, but I'm going to take the natural logarithm just because it's a bit quicker to write. So I'll take the natural logarithm of this side, and I'll also take the natural logarithm of this side. I can pull the power down to the front. Hopefully you remember that log law, so I can pull the power down to the front on both sides. I might not need to have pulled the power down to the front of this side, but it's probably worth just doing the same thing on both sides. So I'm going to now divide by ln4. So 3p minus 1 is 210 ln 5 divided by ln 4. I'm then going to add 1, so that 3p is 210 ln 5 over ln 4 plus 1. and then I'm going to divide by 3. So I'm actually just going to say this thing is a third of that. So that's 210 ln 5 over ln 4 plus 1. Okay, so let's put that on the calculator. We're going to do a third brackets 210 ln 5 over ln 4 plus 1. So we get 81.6. So P is equal to 81.6, and that's to 1 decimal place. Don't need to write the 1 decimal place, but we're just going to write that in anyway. Okay, question 3. Relative to a fixed origin, we have these 3 different points of A, B, and C, and we're going to start off by finding A, B. Now we know that A, B is the second letter, subtract the first letter, and we're going to do this as column vectors. So B is 3 minus 3 minus 4, and A is 2, 5, minus 6. So when I do this calculation, 3 minus 2 is 1, minus 3 minus 5 is minus 8, and minus 4 minus minus 6, that's minus 4 plus 6. That's 2 that we have there. So we've got the answer 1 minus 8, 2. The next part, it says, show that the quadrilateral OABC is a trapezium, giving reasons for your answer. So a trapezium is something that looks like this, and they've said that it's OABC. Now we don't know which side is going to be the parallel sides for a trapezium. A trapezium has 1 pair of parallel sides. But I'm guessing, because they've asked us to find out what AB is, I'm guessing that AB is going to be parallel to the other side. So the way you label it, it goes OABC. That means you start with the origin, A, B, C. It kind of goes around like in a clockwise or anti-clockwise direction for this. So I'm going to see what AB and OC look like. So we've got what AB is up here, and OC is the position vector of C, which we have at the top. So that's 2, minus 16, and 4. So having a look at comparing OC with AB, we can see that OC is 2 lots of 1 minus 8, 2, which means it's 2 lots of AB. So we're saying here that OC is equal to 2 lots of AB. What this means is OC and AB are parallel and not equal in length. In fact, OC is twice the length of AB. Hence, OABC is a trapezium. If they were the same length, it would be possible that it could be a rectangle or a parallelogram or a square, so you'd have to be careful for that. Okay, next question that we've got here, it is a functions question. So part A of the question says, find what happens when you put 7 into the inverse function. Now, this is actually just saying, find out when the function is equal to 7, because it's only a 2-mark question. You might want to find the inverse function and then sub 7 into it, but actually it's just saying make this thing here equal 7. The only options you can really do, if it was that, you put 7 into the function, but because we've got that, we make the function equal 7. So I'm just going to solve this equation. So 3x minus 7 is equal to 7 multiplied by x minus 2. 3x minus 7 is equal to 7x minus 14. So I'm going to subtract the 3x, which gives me 4x minus 14, and then I'll add the 14 so that I get 7 equals 4x, and then I'll divide by the 4, so x is equal to 7 over 4. Part B of the question says, show that f of f of x is ax plus b over x minus 3. So that means we're going to take the function and we're going to put it back inside the function. So f of x means anywhere that I see x in this bit, I'm going to replace it with the overall function that we have. So that's 3 lots of 3x minus 7 over x minus 2 minus 7 all over 3x minus 7 over x minus 2 minus 2. Now we don't like fractions within fractions, so what I'm going to do is I'm actually going to multiply the top and bottom by the same thing to try and get rid of those fractions within fractions. I'm going to multiply everything on the top by x minus 2, and I'm going to multiply everything on the bottom by x minus 2 as well. So in the numerator, I will just be left with this part at the top, because the x minus 1, not the whole numerator, but just that part. So I'm going to get 3 brackets 3x minus 7, And then when I multiply the 7 by x minus 2, I'll get that part. Then on the bottom, when I multiply the first term by x minus 2, I'll just get left with 3x minus 7. And then don't forget to multiply the minus 2 by x minus 2 as well. So I'm just going to do some expanding and tidying up. That's 9x minus 21, not 63, minus 7x plus 14. And then the denominator is going to be 3x minus 7 minus 2x plus 4. Be very careful that it is plus 4 for that one. So we're now just going to continue. Numerator simplifies to 2x minus 7, and the denominator is going to simplify to x minus 3. So that's sort of the form they wanted. It says where a and b are integers to find. So a looks like it's 2 and b looks like it is minus 7 for that question that we have there. Okay, question 5. A car has 6 forward gears. The fastest speed of the car in first gear is 28 and in sixth gear is 115. So we've got first, second, third, fourth, fifth, sixth. This is 28 kilometers per hour, and then the sixth one is 115. Given that the fastest speed of the car in successive gears is modelled by an arithmetic sequence, find the fastest speed of the car in third gear. So if it's arithmetic, we're looking for this third one. Now you could just do this with like common intuition of just thinking, okay, it's going up 1, 2, 3, 4, 5 times, find the difference and divide it by 5. Or you might like to think of more of kind of like the formulae that goes with this. So we're talking about like the term that it is in, the position. So we say that un for an arithmetic sequence is a plus n minus 1 d. Now we know that the first one, u1, is 28. And we know that the sixth one is 115. So that means that 28 is equal to, which we don't need to do anything with 28 because we know that's also what a is equal to. So a is equal to 28. But we know that 115 is equal to a plus n minus 1, which is 6 minus 1, multiplied by the common difference. We're going to find out what the common difference is. So 115 is equal to 28 plus 5d. So I'll do 115, take away 28, and then divide it by 5. 115, take away 28, divided by 5, and we get 17.4. So that means that the common difference is 17.4. In other words, it's going up 17.4 each time. So if I want to find out what the third term is, the third gear, I'm going to say that it is a plus n minus 1 multiplied by 17.4. And you can see what's happening. It's that multiplied by, adding on 17.4 twice. So I'm going to do 28 plus 2 times 17.4, which is 62.8 kilometers per hour. Okay, so the next part that we have here, it says, given that the fastest speed of the car in successive gear is modelled by a geometric sequence, find the fastest speed in the fifth gear. So we're now going to be trying to find this one. Okay, so part B of the question, we still know that the initial was 28, and this time we know that the sixth one was 115. So that means that 115, if you know the general formula, un is ar to the n minus 1. So that means it is going to be 28 multiplied by r to the power of 5. So I'm going to try and find out what r is here. So it's 115 divided by 28 is r to the power of 5. And then you can either do the fifth root or you can do it to the power of a fifth. To the power of a fifth. But I'm going to find out what r is equal to. I am going to do it as the fifth root. So I'll do shift, and there it is over there. Oh, it's got my answer up there. That's a shame. So we'll do the fifth root of 115 over 28. So we've got what r is equal to. R is equal to 1.326, blah, blah, blah. Now, because we're trying to find out the fifth gear, we want to find out what u5 is. That is going to be a multiplied by r to the power of 4. Now, I've already got r on my calculator, so I'm just going to type in 28 multiplied by the answer to the power of 4, and we get 86.7 kilometers per hour. I think it wanted it to one decimal place. If it didn't say, I think one decimal place seems reasonable, so I'm just going to say after here, this is one decimal place, and this is also one decimal place. Question 6. Express sine 2x plus 2 cos x in the form r sine x plus alpha, where r and alpha are constants and alpha is between 0 and pi over 2. So we're definitely going to need to be in radians here, and it does mention that. Now this is what we call the harmonic identity. So that means like the r cos kind of stuff for this. I like to sometimes do a slightly longer version. You could go straight to it, but we're trying to get r sine of x plus alpha. So that is going to be, from the addition formula, r sine x cos alpha plus r cos x sine alpha. So comparing these things together, we can see that the r cos alpha, which goes with sine x, there's a coefficient of 1 there. So r cos alpha is equal to 1. Just going to put that down a line. And then we can see from the other part that r sine alpha, which goes with cos x, is plus 2. So that means that r sine alpha is equal to 2. Now to find out the r coefficient, you literally just do the Pythagoras with these things that you've got here. So that's just 1 squared plus 2 squared. That's root 5. And then to find out what alpha is, well, you do that tan alpha. If you do that one divided by that one, you get tan alpha equals 2. So alpha is equal to the inverse tan of 2. And they want that in radians to 3 decimal places. So let's go back to the calculator. We are going to just shift my calculator to radians, and then I'm going to clear this. I'm going to do the inverse tan of 2 to 3 decimal places. We get 1.107. So because they want it in that form, I'm just going to finish off by actually writing it in that form. So no, it just says give the exact value of r and the exact value of alpha. So we've actually done enough. We don't even need to write it in that form. The temperature theta degrees inside a room on a given day is modelled by this equation. Now, always what you want to do when it's the same kind of theme of question, you want to think, how does this thing that we've got here relate to the original thing that we're talking about? And it says that T is the number of hours after midnight. Using the equation of the model and your answer to part A, deduce the maximum temperature of the room during this day. So let's actually just take this equation that we've got and let's rewrite it. So for part B of the question, theta equals 5. Now this second section that we've got here looks so similar to this. It's just that the x has been replaced with pi t over 12 minus 3. So I think we can replace the whole thing because we know that this can be replaced as root 5 sine of x plus alpha. I can replace that whole section that's got the blue box around it with root 5 sine. Now x, we said, was pi t over 12 minus 3. And I'm going to plus on alpha, which was 1.107. So because we're looking for the maximum temperature is going to be when this whole sine function is equal to 1. So the maximum temperature is just going to be 5 plus root 5. I'll just quickly calculate that. 5 plus root 5. And we get that the maximum temperature is 7.236. Did it want it to anything? I think we'll just say 7.24 degrees centigrade. So now part C, it says find the time of day when the maximum temperature occurs, giving your answer to the nearest minute. So the maximum temperature occurs when sine is a maximum, when this thing here is a maximum. In other words, when the sine of pi t over 12 minus 3 plus 1.107 is equal to 1. Well, if you think about the sine graph, we know when the sine graph is equal to 1, it's when it's equal to pi over 2. So that means we want pi t over 12 minus 3 plus 1.107 to be equal to pi over 2. Let's see if we can start solving this equation. So pi t over 12 is going to be equal to pi over 2 plus 3 minus 1.107. Let's put that all in the calculator. So I'm going to do pi over 2 plus 3 minus 1.107. So that's what pi t over 12 is. My calculator's jumping all over the place. Remember, we're trying to find out what t is. I'll just put some dot, dot, dot. So I'm going to just finish solving that equation by multiplying the answer by 12 and then dividing the answer by pi. So it looks like t is 13.2307, okay? But they've asked for it given in a particular form. They want it find the time of day when the maximum temperature occurs, giving your answer to the nearest minute. Now it was started being measured, let's see if it tells us one, after midnight. So it's 13 hours after midnight. So I think that the time is going to be in the 24-hour clock, it's going to start with a 13. So we just need to investigate this 0.2307. If I multiply that by 60, it will change it into minutes for me. So I'm going to just do, let's subtract the 13, so I've got that, and then I'm going to multiply that answer by 60. So to the nearest minute, that will be 14 minutes. So it is going to be 14 minutes, meaning that the time is 13:14. That is when it's going to be. And I guess we could have said 13 hours and 14 minutes after midnight. We could say 13:14. You could say 1:14 p.m. All sorts of answers would be accepted for that. Okay, question 7. It says the figure shows a sketch of a curve with the equation y equals f of x and a straight line L. The curve C meets L at the points -2, 13 and 0, 25, and the shaded region is bound by C and L as shown in figure 1. Given that f of x is a quadratic in x and that -2, 13 is the minimum turning point of y equals f of x, use inequalities to define R. So I think what we're really going to need to do is we actually just need to find the equations. So we need to find the equation of L and C, and then we'll worry about the inequalities afterwards. Let's start off with L, because I think L is going to be the easiest. Remember, for the equation of a line, we can do the GCSE version because we actually already know the y-intercept, which is 25. So we just need to find the gradient of the line. So for the line that we've got here, the 2 points are 0, 25 and -2, 13. So let's find out the gradient of the line by doing the change in y. So I'll do 25 take away 13 over the change in x, which is 0 minus -2, which is 0 plus 2. 25 take away 13 is 12, so that's 12 divided by 2, which is 6, which means the equation of the line, I don't have to use the y minus y1 equals m brackets x minus x1 formula, because I already know that the y-intercept is 25, so I can just say y equals 6x plus 25. Now we're going to think about the curve for a second. We know that the curve has got a minimum turning point at -2, 13. So if we were going to think about what that would look like, we know that if it's got a turning point at -2, 13, it would be x plus 2 squared plus 13. However, remember, it needs to go through 25. So we actually need to have a scale in front of this in case it doesn't go through 25. And in fact, when x is equal to 0, you get 13 plus 2 squared, 13 plus 4, you get through 17. So it doesn't actually work there. So we're going to need to make sure that this goes through the coordinate 0, 25. So for C, y is equal to a brackets x plus 2 squared plus 13. And we know that when it is going through 0, 25, x is equal to 0 and y is equal to 25. So 25 is equal to a, and then x is 0, so that's just 2 squared plus 13. So I'm going to solve this equation. I'll do 25 take away 13, which is 12, and a at 2 squared is 4, so that's 4a. 12 divided by 4 is 3, so a is equal to 3, meaning that the equation of this curve is that y equals 3 x plus 2 squared plus 13. So these are my two equations, that y equals 6x plus 25 and y equals 3x squared plus 13. So we've done the things we said to begin with, which was to find the equation of L and C, and now we're just going to try and define this region. And it says use inequalities. It doesn't say set notation. You could do set notation if you wanted to, but I just want to define this area. So it is where the y coordinates are bigger than this curve, and when they are less than the line. Notice how I said and. It's not or in this case, it is definitely an and. So I want to make sure that the y coordinates are bigger than the 3 brackets x plus 2 squared plus 13, meaning it's above that curve, and I want them to be below the line that looks like this. Now, if you look at the lines, they are solid lines, which means that we also need to have these or equal to signs that go with this stuff that we've got here. Okay, so does it actually say anything about the way it's bounded? Yeah, so it doesn't have to have those lines. I'm just double checking with the mark scheme that we go for this. Yeah, so you could have it with either of the inequality signs. They would have accepted it without those in as well. Okay, let's have a look now at question number 8. A new smartphone was released by a company. The company monitored the total number of phones sold at time t days after the phone was released. The company observed that during this time, the rate of increase of n was proportional to n. Use this information to write down a suitable equation for n in terms of t. So you might already know what this relationship is, but I think for 2 marks this is a pretty sort of tricky sort of question. My brain would be like, okay, let's just quickly write what this means. The rate of increase of n. So dn dt, it says that it is proportional to n. When something is proportional, that means you can say that it is equal to like kn, like this. Now you might know what this is going to be, but actually I think I'm going to just solve this as a differential equation. So I'm going to put the dt up to that side, and I'm going to bring the n to the other side as a 1 divided by. So I get 1 divided by n, dn, is equal to k dt, and then I'm going to integrate both sides. When you integrate 1 over n, you get ln of n, and here we get kt plus a constant c. So just rearranging this, I get that n is equal to e to the power of kt plus c. And that's what they're looking for. Now there's so many different types of things that they would accept for this. They would have accepted it if you rearranged it and said that it was a e to the kt, where a is a constant. They would have accepted it even if you had something like, I'm just going to see what other ones they've got. They would have even said something like a equals, a k to the power of t, I think. No, I'm not going to leave that last one there. But I think these are the 2 most common forms that you'd expect to see for this. But for 2 marks, I just think it's not particularly nice of them to have done. Okay, let's have a look now at question 9. So the figure 2 shows the sketch of the curve with this equation, and we're going to show what the first derivative is of this curve. So it looks like it's going to be a product rule type of thing. So I'm going to say that for this thing, u is 4x squared minus 2. You might like to expand the brackets, so that's 4x squared minus 8. And v is e to the minus 2x. So I'm going to differentiate this by finding out what u dash is. That's going to be 8x. And v dash, that is going to be minus 2 e to the minus 2x. The product rule is when we do these 2 multiplied and these 2 multiplied. So f dash x is going to be, if I start off with these 2 being multiplied, not that it really matters. Actually, I'm going to do the other 2 because then I start with a positive. I'm going to do 8x multiplied by e to the minus 2x, and then I've got minus 2e to the minus 2x, 4x squared minus 8. Now they want it to be looking like this, so I'm going to just expand everything and then factorize to look at like this as well. I have 8x e to the minus 2x minus 8x squared e to the minus 2x plus 16 e to the minus 2x. So if I take out the factor now of the e to the minus 2x, I get left with 8x minus 8x squared plus 16. And now I can also take out a factor of 8, and then I can put that at the end. It doesn't matter if this e to the minus 2x is at the beginning or not. So if I take out a factor of an 8 as well, I get 8e to the minus 2x, x minus x squared plus 2. Now it's almost the same as what they've written. I'm just going to say that I can put it in a slightly different order. So they have 2 plus x minus x squared. So I'm going to just rewrite that. So that is 8 brackets 2 plus x minus x squared e to the minus 2x. That's what f dash x is equal to. Okay, part B, it says, hence find in simplest form the exact coordinates of the stationary points. Now, stationary points, that means that there's plural here. It's when the first derivative is equal to 0. So I want this first derivative to be equal to 0, which means I want 8, 2 plus x minus x squared e to the minus 2x to be equal to 0. Well, you can divide by the 8. And e to the 2x, negative 2x, that cannot be equal to 0. It's always greater than 0 because e to the minus 2x is always greater than 0. So that means we want 2 plus x minus x squared to be equal to 0. And as a normal quadratic, that's minus x squared plus x plus 2 equals 0. Now this calculator doesn't have the simultaneous equation solver, but your calculator does, and I've just got it on the side here with me. So I'm just going to quickly solve that equation on the polynomial. It's minus 1, 1, and 2 for the coefficients. I could have factorized it, but I'm being very lazy. So x is equal to 2 or x is equal to minus 1. So it's good that we've got two coordinates because it did say find the exact coordinates of the stationary points. So now I actually need to find out the y part of this. So my original equation is that f of x is 4 brackets x squared minus 2 e to the minus 2x. So let's just zoom out so I can hopefully see that at the same time. So I want to say that the y coordinate is going to be 4, this is if x is equal to 2, 4 multiplied by 2 squared, which is 4 minus 2, e to the minus 2x, so that's e to the minus 4. So that is going to be y equals 4 multiplied by 2, so that's just 8 e to the minus 4, meaning that one of the turning points is 2 brackets, 2 comma 8 e to the minus 4. Now, if x is equal to minus 1, y would be equal to 4 brackets x squared, that's 1, minus 2, e to the minus 2 times minus 1, that's e squared. So that is 4 multiplied by minus 1 e squared, in other words, minus 4 e squared. So the coordinate is minus 1 and minus 4 e squared. Let's just see if they look like they're in the right sort of place. So we had 2 with something that was up here, great, and then we had minus 1 that was something negative down there. Good, so these seem like reasonable kinds of coordinates that we've got. Now part C of the question is where it gets a little bit funky, a bit different. It says the function g and the function h are defined by these two things that we've got here. The first thing that I notice about both of them is that the domains are different. The first one has everything included. The second one has only got the positive parts of the graph. This whole section over here is being disregarded. And it wants us to find the range of g and then the range of h. The range of the graph is how much of the y is being sort of included. So it looks like this section of the graph is just going to keep going up forever and ever and ever. So when I'm talking about the range normally, I would say that the range of this graph is whatever this value here is. If I just said it was k, the range of f of x is that f of x is just greater than or equal to k. But the graph we're talking about is 2f of x. In fact, we even knew what that k was, didn't we? I think we said it is this, minus 4e squared. That value of k is minus 4e squared. So we could have even answered that question and said that it was minus 4e squared. The difference is, in this transformation, everything is being stretched. So instead of the range being greater than minus 4e squared, it's going to be greater than or equal to minus 8e squared. So for g of x, we're going to say that it is greater than or equal to minus 8e squared. Then we're going to think about the next part. It wants us to talk about the range of h. So this means the graph is being doubled and it's moving 3 positions downwards. So we can also totally disregard this whole section of the graph because they've said that the domain is greater than 0. So I think we're now going to need to find out what would this coordinate be for the graph. Well, let's see what it is for the original graph. For the original graph, when x equals 0, we would get that the y-intercept is 4 times by minus 2 e to the 0, which is just minus 8. So right now, that coordinate is minus 8. For the new graph, because we're talking about the range, the new graph's range, we're talking about in between this bit and this bit here. That is the range if we got rid of this whole red section that we have. So I think we're going to now have a look at what the bottom end should be for h of x. For h of x, we're going to say that it has got to be greater than or equal to, well, it's got to be greater than minus 8, but we're doubling that to minus 16, and then I think we're adding on, taking away 3. Yeah, we're doubling it and then taking away 3. So I'm going to take that minus 8x, or sorry, minus 8. I'm going to double that, and then I'm going to take away 3. So that means it's now going to be at minus 19. Let's now think about what's happening at the top end. Well, this is the coordinate of the maximum point on the original graph, which is 8e to the minus 4. So this is 8e to the minus 4. So the range of the original one, if you got rid of this red section, is between minus 8 and 8e to the minus 4. We're going to double that and then subtract 3. So I'm going to double that to get 16e to the minus 4, and then I'm going to subtract 3. So the original one was that it was between minus 8 and 8e to the minus 4. So you'll notice how we've doubled and subtracted 3 on those things that we've got there. Pretty difficult question for that, particularly because they've just disregarded this whole part by saying x is greater than 0. Okay, let's have a look at question 10, a substitution question. So we're going to use the substitution that x is equal to u squared plus 1. It's weird that the dx is here. Normally the dx is at the end, but it doesn't really matter. It's exactly the same kind of thing that we've got. Now there's a number of different things we're going to need to do. One of the things is changing the limits, and I think I'm going to start off by doing that because that looks like an easy part to get some marks. So the x currently is 10 and 5. We're going to want to change those so that it's in terms of u. So when x is equal to 10, we would have that 10 equals u squared plus 1. So that's 9 equals u squared, or u is equal to 3. And when x is equal to 5, we would get 5 equals u squared plus 1. So 4 equals u squared. So the square root of 4 is 2. So the new limits, instead of 10 and 5, they're going to be 3 and 2. So I've done with those bits there. The 3 is fine. I think the x minus 1 is going to be really easy. So this little x minus 1 part that we've got here, if x equals u squared plus 1, x minus 1 is going to be equal to u squared, so I've got that part. And I think this bit's going to be really easy as well, because if I want to do the square root of x minus 1, that's just going to be equal to u. So it looks like I've got all of the different parts that I need. So I'm just going to copy it out so that I've got it to refer to. So integrating between 5 and 10, I'm going to put the dx at the end, or I don't have all the bits that I need because I don't have the dx. I'll come to that in just a second. So that's 3 over x minus 1, 3 plus 2 root x minus 1. So I still need to figure out what dx is. I've got all of the parts to substitute, but I haven't got that. Now they've told me at the beginning that x is equal to u squared plus 1. So I'm going to differentiate that so that I get dx du is equal to 2u. Which means if I'm trying to find out what dx is equal to 2u du. So I'm going to highlight all of the things that I need. I need to use the limits, which I have here. I need to change the x minus 1, which I have here. I need to change this square root of x minus 1, which I have here. And I need to change dx to this thing that I've got here. So let me just pull this down so that I've got enough space to do the equal sign. So I am going to change the limits. Instead of at 10 and 5, it is a 3 and 2. The 3 will stay there. The x minus 1 is u squared. We then have 3 plus 2u. And then dx is 2u du. Let's see if we're getting close to what they've got. So they've said it's 6 du over u, 3 plus 2u. Oh, great. Okay, so I think I can see some things that will cancel. I think this u will cancel with the squared part, and then I can multiply the numerator so that I get 3 times 2, that's 6, over u brackets 3 plus 2u. I've got the du at the end, but they've got the du as part of the whole thing, which is quite unusual. I don't see many questions that look like that, but we've now come up with exactly what they wanted to show. Okay, so unsurprisingly, it says, hence using algebraic integration, show that it is equal to ln a. So part B of the question is actually just to kind of do the integration. So part B, this looks like, I'm going to get rid of that. I don't like the du in the place that it is. I'm going to just say that the du is over here. I'm going to try and integrate 6 over u brackets 3 plus 2u. Now, you can't do that yet. You actually need to write this as partial fractions in order to be able to do it. So I'm going to do a over u plus b over 3 plus 2u. So that means 6 is equal to a brackets 3 plus 2u plus bu. So I'm going to say if u is equal to 0, we would get that 6 equals 3a. In other words, a is equal to 2. And we can now say if u was equal to minus 3 over 2, we get that 6 is equal to, that would make this whole thing become 0. That's why I picked minus 3 over 2. That would be that 6 is equal to minus 3 over 2 b. So I'm going to do 6 times 2 divided by 3. That means that b is equal to minus 4. So a is 2 and b is minus 4 for this particular one. Okay, now what we're going to try and do is actually do the integration. So we're integrating between 2 and 3. A over u, which is this thing that we have here, that's 2 over u, minus 4 over 3 plus 2u du. So from integration, we know that 2 over u is going to integrate to 2 ln u. And the next part is also going to be an ln of 3 plus 2u, but that would only differentiate to 2 on the top because of this part, but we want it to be a 4, so it also needs to be with a 2 as well, and that's between 2 and 3. So I'm going to substitute 3 into this, so I get 2 ln 3 minus 2 ln of 3 plus 2 times 3, that's 9. And then I'm going to subtract 2 ln 2 when I substitute 2 in here. This next part is going to become a plus, so it's going to be plus 2 ln of, we have 3 plus 2 times 2, so that's ln of 7. So now I just need to think about how all of these things can combine into a single part. Well, they've all got a 2 with them, so I could factorize out a 2, so that's 2 ln 3 minus ln 9 minus ln 2 plus ln 7. So we can do the adding ones first. That is going to be multiplying those two numbers together. 3 times 7 is 21. And then I'm going to do these two, that is minusing ln 9 minus ln 2. So that is ln of 21, we divide it by 9, and we also divide it by 2. So we have the ln of 21 over 9 times 2, which is 2 ln of 21 over 18. I can divide the top and bottom of that fraction by 3, so that is 2 ln of 7 over 6. I can put that 2 back inside by changing it to a square, so it's the ln of 49 over 36. I think that ln stuff at the end was a bit tricky. These ones multiply. You then divide it by both of these, which is the same as dividing it by 18 that you have here. And again, if I had more time, I would put the original thing that's here, I would type that onto my calculator, and I would also, and then see what it came up with, and I would guarantee it will come out as ln of 49 over 36. Pretty tough question, but it was 10 marks, so it was hopefully worth it. Okay, question 11. A circles kind of question. It says we've got the equation of circle 1, which is x squared plus y squared equals 100. So we can clearly see it's centered here, and we know that the radius is 10, so I can immediately spot some of those things about it. And then circle 2 has the equation x minus 15 squared plus y squared equals 40. So I know that the center of this circle, that is 15. Okay? We also know that the radius of this one is the square root of 40. I'd just like to kind of add some of those things in. I think that can be good to help us with the diagram. The circles meet at the points A and B, as shown in figure 3. Show that angle AOB is 0.635 radians to 3 significant figures. So that means it wants me to find out what this angle here is, the angle between them here. So I think what we need to do is we need to find out something about these coordinates of A and B. Now it's said where the two circles intersect, so I actually think that means to do simultaneous equations. So I'm going to start off by doing x squared plus y squared equals 100, and my second equation, which was x minus 15 squared plus y squared equals 40. Now I think the simplest substitution here is either to subtract the equations, the simplest way of doing this is either to subtract the equations to get rid of y squared, or you could just make y squared the subject of the first one. So if I make y squared the subject of this first one, I get 100 minus x squared, and I can then substitute that in here. So I get x minus 15 squared plus y squared, which is 100 minus x squared, equals 40. Expanding these brackets is x squared minus 30x plus 225 plus 100 minus x squared equals 40. The x squared and the minus x squared cancel, so I then have minus 30x plus 325 is equal to 40. So I'll put the 30x onto the other side, and I'll do 325 take away 40, being very lazy here, which is 285. So I'll do 285, and I will divide that by 30 so that I get the x coordinate is 9.5. Now I could find out the y coordinate if I want it, but I think this might be enough. So what this means is this number that we have here is 9.5. Now we're trying to find out what the angle is. I know something about the length of this line that we have here. That line is the radius of the circle, so it's 10. And this line from here to where the x coordinate of this intersection, because the coordinates of A and B have got an x coordinate of 9.5, that's what we just worked out. This length is 9.5. So I think I've got a right angled triangle here, which means I can find out that angle. I'm going to draw that triangle out though. So for that triangle that we've got, here is O and here is A. We've said this is 9.5 and this is 10. And I'm going to find out what this angle is over here. If I just call that theta for now. So I can use my trigonometry from GCSE. I have the adjacent and the hypotenuse. So cos theta is the adjacent over the hypotenuse. So theta is the inverse cos of 9.5 over 10. Which means the angle that we want, if that top part is theta and we want the whole angle, we're just going to have to do that angle doubled. So angle AOB is that angle doubled. So angle AOB is equal to 2 theta. So I'm just literally going to type that and times it by 2. So I'm going to do the inverse cos. I think I'm in radians still. Good, I am. I'm going to do the inverse cos of 9.5 over 10. I'm going to get that angle. I'm going to multiply it by 2, and I get 0.635 to 3 decimal places. Is that what it said? Yep, to 3 significant figures. 3 significant figures. Pretty hard question, I think. The region shown shaded in figure 3 is bounded by C1 and C2. Find the perimeter of the shaded region, giving your answer to 1 decimal place. So we want to find out the perimeter. In other words, we want to know, this is going to be terribly drawn, I'm sure, that and all of this that we have here. Very wobbly. Now, I already know what this angle is. This angle is 0.635. So that's going to help me to find out this sort of like red section that we have here. Okay, so the large part for C1 between A and B. So for C1, AB, well, we have the formula for the arc length. The arc length is just r theta. So AB, the arc AB, is the radius multiplied by theta. Now, if the inside angle is 0.635, the total angle is 2 pi, so we'll minus 0.635 from that, and we'll find out what that is in just a second. And then for the second curve, we need to do the same thing. We need to find out what the arc AB is, but going in the other direction. Well, we don't know what that angle is, so we need to do some more work to figure out what this angle over here is, what this bit, they look like Pac-Man now. So we could do some of the same thing that we had in the previous part, okay? I'm going to highlight this triangle and draw this triangle out separately. It's very thick. Let's see if I can draw that a little bit smaller. So I'm going to try and draw this triangle. I'm going to draw it here for a second, and then we can also do it at the bottom of the page. Now we know how long the hypotenuse is. The hypotenuse, because this circle has got a radius of minus 40, the hypotenuse is the square root of 40. And we actually know what the bottom part of this triangle here is, because it's the difference between 15 and 9.5, which is 5.5. So if I call that angle there alpha, I can find out what is going on. I can say that the inverse cos of alpha is going to be, inverse cos of 5.5 over root 40 will give us alpha. We can double that, take it away from 2 pi, and then do the exact same thing. They're making you do a lot of work here. So let's just quickly say for our alpha section that we've got, we're going to say that alpha was the inverse cos of the adjacent, which was 5.5 over the square root of 40. And then if we double that, we get what the angle is. So I'm going to say that the arc for AB is going to be the radius, using this r theta formula that we've got. It's the radius, which is the square root of 40. And we're going to do 2 pi minus 2 alpha. I'm not going to bother putting this whole thing into the calculator and writing it as a number. I'm just going to store this on the calculator as alpha that we've got. So let's just work it out. We're going to do the inverse cos of 5.5 over the square root of 40. That's what alpha is. So I can store that. Shift, store. Oh, I don't know if I'm going to be able to do that. I'm just going to leave it there as my answer button. So I'm going to find out now what the perimeter is by adding both of these things together, okay? So I'm going to say that it is 10 2 pi minus 0.635 plus, let's just do it so I can see it all at the same time, plus root 40 2 pi minus 2 alpha. So, damn it, now I'm going to have to do alpha all over again. That's okay. So we'll do the inverse cos of 5.5 over the square root of 40. If I typed it in correctly, would have been better. My apologies. And then we've got that value of alpha. That's the one that we're going to be putting in here. So I'm going to do 10 brackets 2 pi minus 0.635 plus root 40, open up the brackets, 2 pi minus 2 of what we have on the calculator. And we get the answer 89.6888, and they wanted it to one decimal place, I believe, which is 89.7. Did they say one decimal place? Yep, they did. I think that's a lot of work for 4 marks. I think it's not particularly nice of them, but it's 89.7 units. Okay, we are now on to question 12. Question 12, show that cosec minus sine theta is cos theta cot theta. I actually think this is a really difficult exam. Okay, so I'm going to also put in the description, I'm going to put what the grade boundaries were so that you can get an idea of how many marks you could sacrifice when you're actually doing this. So I think this is going to be the better side to work on because I can actually do some maths to it. It's quite hard to pull this apart. It's a lot easier to put these two things together. So cosec is 1 over sine theta, and I'm going to be subtracting sine theta. Keep working on this side that we've got here. I'm going to make them have a common denominator. So that's going to be 1 minus sine squared theta all over sine theta. I just multiplied this second one on the top and bottom by sine theta. Now, when you see 1 minus sine squared, you should immediately think of cos squared. So I have cos squared over sine theta. Now this is cos theta over sine theta multiplied by cos theta. And cos theta over sine theta is cot theta. So we have cot theta, cos theta, which is exactly what they wanted us to show here. So then it says, hence or otherwise solve between 0 and 180 this equation. So I'm just going to write it out so that I've got it to refer to. It is cosec x minus sine x equals cos x cot 3x minus 50, and it's all in degrees here. So always what you do in these questions is whatever you've just done in the previous part of the question, which we see here, just replace it with what we said it was equal to. So I'm going to replace it not with cot theta, but with cot x cos x. And now I can just continue. So I get cos x equals cot of 3x minus 50. So the first thing that I can do is divide both sides by cos x. But when you do that, that means that cos x could be equal to 0. So when you solve that equation, we get the solution that x is equal to 90. I'm just going to switch back to degrees mode. You should know this one by heart though. If you do the inverse cos of 0, you get 90 degrees. And between 0 and 180, there's not going to be any other solutions. So this is the weird part. I've never seen a question like this before, but they've got that cot x is equal to cot of 3x minus 50. Now you might think you're going to have to do some kind of expansion here, but actually we can just compare both sides. I tell you what, I'm going to make it feel a bit more friendly by changing it to tan x. I'm just going to take the reciprocal of both sides. Still going to give you exactly the same thing though. Now, by comparing these things, actually we can just say this thing must be equal to this thing if they're going to be equal to each other overall. So we get that x must be equal to 3x minus 50. So I'm going to subtract the x, which gives me 2x minus 50. I'll plus the 50 and I'll divide it by 2. So that means that another solution is that x is equal to 25. Now this is the sneaky part. Because it's tan, we know that tan repeats every 180 degrees. So I'm also going to be able to add 180 to this thing and solve that equation, and that might give me another solution. This is so sneaky. I don't think I ever would have seen this as a teacher as well. So x is equal to 3x minus 50, but I'm also going to add on 180 because x should also be equal to that as well if it's 180 bigger. So x equals 3x plus 130. So we then get, let's see if this is going to work. Yeah, it is going to work. So then we get 0 equals 2x plus 130. So I'll subtract the 130 and divide it by 2. So x is minus 65. Well, that one isn't the region, so that's not actually going to be one that we include. But we could also do it if we had 180 added to the original one. So I'm going to try one final one, which is x plus 180 is equal to 3x minus 50. So I've done this one where I added the extra 180 on over here. I'm going to do this one where I add the extra 180 on over here. So if I subtract the x, I get 180 is equal to 2x minus 50. That gives me 230 is equal to 2x, or 115 is equal to x. So it looks like I've got three solutions. That one we wouldn't include. So x is equal to 25, 90, or 115 degrees for this. So there's those three solutions of 25, 115, and 90. Now you could think, okay, well, what about if I added 360 onto this? Well, it's going to get too big. And if you added 360 onto this one, or you did it to both of them, you're just going to get the same equation that you have as this original one here. I think that question is really, really hard. I think I probably wouldn't have got this third solution myself. So I'd already be dropping some marks on this kind of question. Like I said, I'll put the grade boundaries in the description so you can see how tough this paper really was. You're aiming, I think, something about 55% for an A, so really, really low, maybe a little bit more. Okay, I'm just going to have a quick sip of water. Okay, question 13. A sequence of numbers is defined by this formula where k is a constant, and the sequence is a periodic sequence of order 3. That means that when you have a sequence, it's like it goes x, y, z, x, y, z, x, y, z. It means it repeats itself, and it repeats itself so that there are 3 terms in each section. That's going to be really important. And they also tell us that a1 is equal to 2. So using this formula, I can find out what a2 is, what a3 is, and then hopefully I can connect all of this together to come up to this thing that we've got here. So I'm going to write down the formula so that I don't have to keep referring to it. So that's an plus 1 is equal to k brackets an plus 2 over an. And they've told us that a1 is equal to 2. So I'm going to begin by finding a2, which means I'm going to do k multiplied by 2 plus 2 over 2. In other words, 4k over 2, which is 2k. Great, so I've got that a1 is equal to 2. Let's put this over here so I've got some more space. a2 is equal to 2k. Let's keep going and find out what a3 is. That means, using this formula, you do k multiplied by the previous one, which is 2k plus 2, divided by the previous one, which is 2k. So that is 2k squared plus 2k divided by 2k. Now I can split that numerator up so that I get 2k squared over 2k plus 2k over 2k. 2k squared divided by 2k, the 2's cancel and the k cancels with that, so you get k plus 1. So I've now got that a3 is equal to k plus 1. Now if it's periodic, a4 must be a1 because it's going to repeat. Do you remember when we said here the fourth one, first, second, third, the fourth one must be the same as the first one. So I'm going to find out what A4 is, and I know it's going to also be equal to 2, but I'm going to keep going in the way that I've done this. So A4, using the formula, is k multiplied by the previous one, which is k plus 1, plus 2, divided by the previous one, which was k plus 1. So we get k squared plus 1 plus 2 is 3, k squared plus 3k over k plus 1. That's what A4 is equal to, k squared plus 3k over k plus 1. Or we're now saying that it is equal to k squared plus 3k over k plus 1. So because it is periodic, we know that this and this, they must be the same as each other. We know that it's going to go 2, this must be a 2. So I'm going to say, as it is periodic, order 3, k squared plus 3k over k plus 1 must be equal to 2, which was the first term. So we get k squared plus 3k equals 2 brackets k plus 1. K squared plus 3k equals 2k plus 2. They wanted it as a quadratic, so I'm going to do k squared plus k. 3k minus 2k is k, minus 2 equals 0. Let's see if that's actually what the question wanted. Yep, it says show that that is the case. Great. So it says for this sequence, explain why k cannot be equal to 1. Okay, well, let's actually just finish by solving this equation. So if I just quickly solve this, because it might help me later on in the question, I'm just going to be really lazy and use my equation solver on the calculator. So I've got 1, 1 and minus 2. So either k is equal to 1 or k is equal to minus 2. But they've just said that k can't be equal to 1. Well, if k was equal to 1, our sequence would be this. A1 was 2. A2 we said was 2k. So that would be 2 times 1, which is 2. A3 would be equal to k plus 1, which is 1 plus 1, which is 2. So if k was equal to 1, we're not getting a sequence that is periodic of order 3. So if k equals 1, the sequence is not periodic order 3. The fourth term would have been the same as the first term, but we need it to repeat every 3, not every single term. So because k is not equal to 1, that must mean that k is equal to minus 2. So we're now going to try and find out the value of this, the sum between r equals 1 and 80 of AR. We're going to try and find out the sum from r equals 1 and 80 of AR, and we know that k is equal to minus 2. So this actually means we're going to be doing A1 plus A2 plus A3 plus A4 all the way up to A80. Well, we have said that k is equal to minus 2. A1 is 2. A2, if we go back to what we wrote earlier on, A2 is 2 times that, and A3 is k plus 1. So A2 is 2k, which is minus 4. And A3 is k plus 1, which is minus 1. Now, if you do A4, you would get that A4 is equal to 2, A5 is minus 4, and A6 is minus 1. You get this pattern that's repeating loads and loads and loads. So for 80, we're going to have lots of these groups of 2 plus 4, 2 minus 4, minus 1. And we need to work out how many of those groups we're going to have for 80. So if I do 80 divided by 3, we're going to have 26 lots of the 2 minus 4 minus 1, because we're going to have 26 groups of these triplets that we've got here. And then it says 0.666, meaning that there's 2 extra bits. There's 2/3, which means it's going to go 2 minus 4, 1, 2 minus 4, 1. And then at the end, we've got an extra 2 and an extra minus 4. So there's an extra 2 and an extra minus 4. All that's left to do is actually to calculate this. So that's 26 brackets 2 minus 4 minus 1, close brackets, plus 2 minus 4. And we get that the answer is minus 80. Pretty tricky there, but we are getting towards the end of the paper. And like the further you get towards the end of the paper, the more likely there's going to be these kind of problem-solving type questions. Okay, question 14. A large spherical balloon is deflating. At time t seconds, the balloon has radius r and volume v. The volume of the balloon is modelled as decreasing at a constant rate. Using this model, show that dr dt is equal to minus k over r squared, where k is a positive constant. So this is connected rates of change, and we're going to try and find out what dr dt is. Now, if you remember with connected rates of change, you take this and you split it into two separate parts. So we're going to be trying to find these two things that we've got here. Now, they told us something. They told us that the volume is decreasing at a constant rate. That means that the rate of the volume changing is decreasing at a constant rate. Now, the reason I've used c is because k comes up later on, but if you did use k, you can just explain later on how you got there. So I know that dv dt is minus c, so I'm actually going to say that that's dv dt. So I'm going to fill in this gap with dv. I need to find out what dr dv is. Now, this is pretty sneaky. They don't actually tell you this, but the volume of a sphere is 4 over 3 pi r cubed. Now, in the mark scheme, they say allow them to say that just the volume of a sphere is just ar cubed, and you can just differentiate that instead. But I don't think many people are probably just going to gamble on that. So unfortunately, I think they should have told you this. I think they should tell you that that's what v is equal to. So because the volume of a sphere is 4 over 3 pi r cubed, we can differentiate to find dv dr. So I'm going to do 4 over 3 times 3, which is 4. So it's 4 pi r squared. Now I can actually go in and find out what dr dv is. Dr dv is the reciprocal of this, 1 over 4 pi r squared. So we get 1 over 4 pi r squared multiplied by dv dt, which we said was something that was leaking at a constant rate. So we can say multiplying it by minus c. So dr dt is minus c over 4 pi r squared. And they've just said, using this model, show that it's equal to this, where k is a positive constant. So I'm going to say, if k is equal to c over 4 pi, then dr dt is equal to minus k over r squared, as they wanted. 3 marks, pretty difficult for that kind of stuff. I think hopefully we all could have come up with this first part here, which does give you 1 out of those 3 marks, just to say that it's leaking at a constant rate. Okay, it then says, given that the initial radius of the balloon is 40, so that means when t is equal to 0, r is equal to 40. After 5 seconds, so when t is equal to 5, the radius is equal to 20. And it says the volume of the balloon continues to decrease at a constant rate until the balloon is empty. That's not going to be that useful for us. Solve the differential equation to find a complete equation linking r and t. So we're going to need to use this information up here in just a second. Okay, so we're going to take, for part B of the question, dr dt is equal to minus k over r squared, and we're going to try and solve this. So I'm going to put the r squared up to the other side, and I'm going to put the dt up to the other side as well, and then I'm going to integrate both sides. So when I integrate r squared, I get a third r cubed, and when I integrate k with respect to t, I get minus kt, and I'm going to add in another constant that I've got here. Now I've already used c, but I'm going to use a different constant this time. I'm going to use alpha. If you wanted to use c, that's absolutely fine. I'm just using something that feels different to what we've been using so far. Now, we said earlier on that when t was equal to 0, the radius was 40, and when t was equal to 5, the radius was 20. So I'm going to take these things here, and I'm going to substitute them into that equation. So for the first one, I get a third multiplied by 40 cubed is equal to alpha. So that is going to tell me what alpha is equal to. Now for the second one, I get a third multiplied by 20 cubed is equal to minus 5k plus alpha, which we've just worked out, which is a third times 40 cubed. So we found out what alpha is, that's great. We're now going to find out what k is. So I'm going to do 5k onto this side, and that's a third of 40 cubed minus a third of 20 cubed. I'm going to put that all on my calculator and then divide it by 5. So I'm going to do a third multiplied by 40 cubed minus a third multiplied by 20 cubed, and I'm going to divide that by 5. So we get that k is 11,200 over 3. So we have nearly got all of the information that we need here. Going back to this equation, I'm going to write out exactly what it is. So I've got a third r cubed equals minus 11,200 over 3t plus alpha, which is a third multiplied by 40 cubed. If I times everything by 3, I get that r cubed is 40 cubed. Let's just quickly work out what 40 cubed is. I'm looking at this second section that I've got here. 40 cubed is 64,000 minus 11,200t. So I've got that equation linked together. If you wanted to make r as the subject and do the cube root, then you can do, but I'm quite happy to leave it in this form. Pretty tough. This is a really, really hard exam. So we've done that bit. It now says find the limitation on the values of t for which the equation in part B is valid. So it only makes sense if the radius of this balloon that we've got here, because we're trying to find the limitation on t, it only makes sense if the radius is greater than 0, which means that r cubed has got to be greater than 0 as well. So that means that 64,000 minus 11,200t has got to be greater than 0. So 64,000, 11,200t, 64,000 divided by 11,200. So let's just quickly work that out. 64,000 divided by 11,200, and we get 40 over 7. So that means that t has got to be less than 40 over a 7. And it could include that, okay? Because we could say that the radius could be equal to 0 when the balloon has become like that. So t has got to be times up to and including 40 over 7 seconds. Very, very difficult. Is this the last question? We've got question 15. I think this is the last, or have we also got a proof by contradiction? We have got 2 more. That's pretty insane. Okay, let's just do question 15 then. So it says the curve has this equation, x squared tan y equals 9, and we're going to try and show that this thing is true here. Now, they are really throwing everything at you at the end of this exam here. We're going to need to differentiate this using the product rule, but there's also implicit differentiation as well. So we have x squared tan y equals 9. Don't worry about aiming for this. We'll get that in a second. Just do the differentiation. So u is x squared and v is tan y. When you differentiate x squared, you get 2x. When you differentiate tan y, hopefully you've memorized that you get sec squared y. But if I just pull this across so I have more space, because you've differentiated y with respect to x, you also get dy by dx. So the product rule is going to be those things multiplied. So I'm going to start off with x squared sec squared y dy by dx plus 2x tan y. And when I differentiate 9, I get 0, okay? Now what I'm going to try and do is make dy by dx the subject, like they've got here, and then I'm going to deal with the fact that they only have x and we've got y with ours. So I'm going to begin by subtracting the 2x tan y onto this side, leaving me with x squared sec squared y dy by dx. So dy by dx is minus 2x tan y divided by x squared sec squared y. Okay, so we want to now turn this so that it's purely in terms of x. Oh, there's something I can do first. I can cancel that x with that bit that we've got here. So we have minus 2 tan y over x sec squared y. Now remember what they told us at the beginning, this thing. So we know something. We know that tan y is 9 over x squared. That's going to be helpful because it means I can replace this thing here, I can replace that with my 9 over x squared in a second. So all I need to do now is really think about how am I going to deal with the sec squared y. So we know that tan y is 9 over x squared. Now there's an identity, right? There's an identity that 1 plus tan squared y is equal to sec squared y. I always tell you to memorize these things because this is why you just need them at the tip of your fingers all the time. So sec squared is 1 plus 9 over x squared. That's what sec squared y is going to be equal to. So I'm going to take this thing here and I'm going to continue working on it. That is minus 2 multiplied by tan y, which is 9 over x squared, and we're going to be dividing by x sec squared y, which is 1 plus 9 over x squared. So for the numerator, we have minus 18 over x squared, and on the denominator, we have x plus 9 over x squared times x is just 9 over x. I hope this is going on the right kind of route here. No, what have I done wrong? Sec squared y. I didn't square over here. Hopefully you've spotted this. So this has not been squared. This thing was meant to be squared. So it's actually 1 plus 81 over x to the power of 4. I didn't square that for what sec squared y was, because obviously that's what tan y is, and this is tan squared y. So let me just quickly go back and fix this. So easy to make mistakes. So it's 1 plus 81 over x to the power of 4. So that is going to change this thing that I have here. It is going to be 81x over x to the 4, which is 81 over x cubed. So I don't like these fractions within fractions. I'm going to multiply everything on the bottom by x cubed and everything on the top by x cubed as well, which is going to leave me with minus 18x in the numerator, and then x to the power of 4 plus 81 on the denominator. Let's hope that's correct. Minus 18x over x to the power of 4 plus 81. Pretty difficult, but we've got what dy by dx is. Now, I can't believe they're about to ask us to do this, but they now want us to prove that it has a point of inflection when x is the fourth root of 27. Now, the point of inflection is when the second derivative is equal to 0, and also when there's like a change in the curve. It goes from being concave to convex. So we're going to investigate that for only 3 marks. I just can't believe how hard this exam is, if I'm honest with you. So for part C of the question, is it part C or part B? Jesus, only part B. Okay, so for part B of the question, we're going to find the second derivative. Now this is going to require the quotient rule for this. So for the quotient rule, we can see that u is minus 18x and v is x to the power of 4 plus 81. So when I differentiate u, I get minus 18, and when I differentiate v, I get 4x cubed. So the quotient rule is when you do these two, subtract these two, divided by v squared. So it's going to be minus 18 multiplied by x to the power of 4 plus 81, minus 18, so it becomes plus 18x, 4x cubed, all divided by v squared, which is x to the power of 4 plus 81. So simplifying this numerator that we've got, we're now just going to say, for a point of inflection, the second derivative must be equal to 0. So I can just concentrate on the numerator, don't need to worry about this bit anymore. Oops, that was also supposed to be squared, because it's v squared for that. So I get minus 18, x to the power of 4 plus 81, plus 18x times by 4x cubed has got to be equal to 0. The reason I didn't multiply by the 18 is because then I can divide everything by 18 here. So that's minus x to the power of 4 minus 81 plus 4x to the power of 4 equals 0. So 3x to the power of 4 is equal to 81, which means x to the power of 4 is 81 divided by 3, which is 27, which means that x is the fourth root of 27. Now, this is where it's even harder, because they also want you for this third mark to make sure that it is definitely a point of inflection and not a maximum or a minimum. So they want us to check either side of this point to see what happens to the second derivative, just for that third mark. It's really, really hard. So when x is equal to the fourth root of 27, the second derivative is equal to 0. When x is less than the fourth root of 27, if we kind of simplified all this thing here, I guess I probably should have done this. This whole numerator simplified to 3x to the power of 4 minus 81. So this is 3x to the power of 4 minus 81 over x to the power of 4 plus 81 squared. So when x is less than the fourth root of 27, this thing is going to be smaller than 81, and it's going to be negative, which means that the second derivative is going to be negative. And finally, when x is greater than the 4th root of 27, using that reverse flipped logic there, we get that it's greater than 0. Hence, when x equals the 4th root of 27, there is a point of inflection. Now, if you just did this bit here, you only get 2 out of the 3 marks. You have to say this last part. That's to show that it is actually making sure that we are going, that it is concave, that it's a point of inflection. I just want to double check I've got it the right way round. So when it's less than 0, yeah, it's this kind of shape. So when it's at the 4th root of 27, it's at 0. This section is where we've said that it is less than 0, and then this section is where it's greater than 0, because it could have been this kind of shape instead. Very, very hard. I actually think the last question is not that hard compared to the other one. So it's proof by contradiction. And when I look at this, I'm going to just immediately get myself a mark by saying, assume for contradiction, there are positive integers, P and Q. Such that 4p squared minus q squared equals 25. Now, when I look at 4p squared minus q squared equals 25, when I look at the left-hand side, I immediately think of the difference of 2 squares, and that's the only thing you can really do here, so just do it. So it's going to be 2p plus q, 2p minus q, equals 25. Now, because p and q are integers, I need to think of what integers could multiply to 25, because if they're integers, that needs to be an integer, and that also needs to be an integer. So for 25, the only numbers are 1 and 25, or 5 and 5. So we could say that 2p plus q is equal to 25, and then 2p minus q is equal to 1. There'd be no point in doing it the other way around, because obviously this one is smaller because it's subtracting something. And I'm just going to be very lazy. I know I could do this quickly, but I'm actually just going to solve it on my equation solver in the simultaneous. Simultaneous 2. So it's going to be 2, 1 and 25, 2 minus 1 and 1. That gives you that p is equal to 6.5 and q is equal to 12. Well, that can't be good, right? That doesn't work because this has no integer solutions. So not both integers. And then we could have said that 2p plus q is equal to 5 and 2p minus q is equal to 5. That's the only other possible thing that it could be. Now, if I go to the equation solver, you can imagine what's going to happen here. We get that p must be equal to 2.5 and q must be equal to 0. And again, they are not both integers. So we have a contradiction. As we don't have any integer solutions. Hence, there are no positive integers. We need to do this concluding statement to be able to get the final mark. There are no positive integers, p and q, such that 4p squared minus q squared is equal to 25. Now, my final kind of thing I want to say about this paper, because this is the end of the paper, is this is hard. You are allowed to drop so many marks, okay? So make sure you're doing some of each question. You're not going to be able to do every part of each question. I mean, for example, I would be dropping this mark. I wouldn't be able to do this part here. There are parts that I think in this were really hard. So you've got to try and use your time in the most sensible kind of way. You are not trying to get full marks. You are trying to get the grade that you need. Check the description. So you can see what the grade boundaries are and reassure yourself that it's going to be easier. It's going to be easier to get the grade than you might think. You're not aiming to be getting like 90% for this. I will continue doing these kinds of series. Please do share Bison Maths with other people. I have started a Bison Maths GCSE channel, so if you've got any siblings that are doing GCSE, do share this with them as well. And good luck with all of your studies.